Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to verify the results on cyclic quadrilateral. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we will be preparing. We will tell the children that what is a cyclic quadrilateral. A quadrilateral which is circumscribed in a circle is called a cyclic quadrilateral. We will try to show them a cyclic quadrilateral. We will tell them that ABCD is a cyclic quadrilateral because ABCD lies on a circle. Now we will tell that the sum of the either pair of the opposite angle of a cyclic quadrilateral is 180. The basic property. We will ask the children to check what is A plus C and what is B plus D by dragging it also, by changing the radius of the circle also. At all the spot, I think they can verify the result by pulling and pushing, and they can go for the converse of this result also. That is, if the sum is 180, then the quadrilateral is cyclic. Let us try to design this dynamic worksheet from scratch. For that, I have selected GeoGebra Classic 5 worksheet and geometry view, and in the option I have selected rounding off to 2 decimal places and labeling of new points only. As usual, let us start with the heading. The heading will be cyclic quadrilateral. It is always better to give a heading and then make this navigation bar to get activated. Okay, now let us try to define the cyclic quadrilateral. A quadrilateral which is circumscribed in a circle is called a cyclic quadrilateral. You can ask the children, then you can declare the statement. Okay, now it is not required, but as usual I will take a slider so that I can go on changing the radius and different circles. I can show it to the children and tell them that the property is common everywhere. But I have taken a slider with n is equal to 1 to 10 with increment of 1. It is left to you. Now let us go for one circle. Now circle with center and radius, I will put it, and then in radius I will call it as small n. Therefore when I move this, the radius will increase. Okay, considerable amount radius I will have. Now as usual we will rename it as capital O because we want the center to be capital O always. Okay, well, now let us take some points, 4 points, maybe concyclic points, number 1, number 2, number 3, number 4. Always take points on object and do it, otherwise it is very difficult for you to put the point exactly on the circle. Sometimes it may go inside or outside also. Okay, now let us try to complete the quadrilateral by taking this polygon, touch A, touch B, touch C, touch D, and then touch E. Fantastic. Okay, you got a quadrilateral. Now when you move it, you are seeing that the quadrilateral is actually very well inside, where it's a cyclic quadrilateral. Where you can tell the children that which is the cyclic quadrilateral, they have to identify. Therefore you can show the children in the text box. Okay, in the text box you can show it to the children that ABCD is a quadrilateral, cyclic quadrilateral. ABCD is a cyclic quadrilateral. Okay, now we will go on exploring the properties. Now one of the very famous properties, the sum of either pairs of opposite angles of the cyclic quadrilateral is 180 degrees. Now you can put it over here. Okay, now how to get the angles? It is very simple. You can go to the angle individually, otherwise go to this angle, simply touch this quadrilateral. Oh, you got it now. Therefore you got all the angles. They have been already named as alpha, beta, gamma and delta. Now you can come and ask the children that what they mean by this. Therefore now you can go to this ABC and you can tell the children that the opposite angle means. What do you mean by that? Go to the symbol and then type it over here. Angle A plus, okay, angle C. Again this angle symbol C is equal to 180. You can go for the symbol. In the basic symbol you are having this degrees. Okay, therefore one thing you can make it over here. Okay, well, now one more thing you can once again in ABC you can tell the children that the other part of it, therefore angle B, you can click it, angle B plus, again click it, that angle symbol will come, angle D is equal to once again 180, the symbol is over here. Okay, now the child should know what actually the value of it. Therefore in the ABC once again you can go to the object property and you can select this alpha from the figure, alpha plus, in the opposite it is gamma, therefore gamma is equal to 180, there is a symbol over here. Okay, now this is the angle A plus angle C is equal to 180. Child can verify it. Then once again for angle B and angle D you have to go to the object property, beta plus, you can go for this delta, it is visible over there, okay, is equal to 180 degrees. Okay, you can type it directly or you can ask the GeoGebra to add it. It will add it and then tell you the same thing. Okay, now you can ask the children to come and verify it by pulling and pushing. You see, when I'm pulling and pushing A, only one B and D is changing. When I do it, then only these two are changing. Therefore, the child can come and verify that actually what is happening now. Okay, B is changing, C is not changing, and so on. Okay, now you can make the statement of the converse of it. That is, if the sum of the opposite angles of a quadrilateral is 180 degrees, then that quadrilateral is cyclic. What is the meaning of cyclic? All the points of the vertices will lie on a cyclic circle. For now, with this dynamic worksheet, what you can do using this navigation bar, you can go and ask the children cyclic quadrilateral, get the definition, then show them a cyclic quadrilateral, then ask them the property of the cyclic quadrilateral, ask them sum of which and which is 180, then you can declare it, ask them to come and verify, and you can ask them to check the converse of it also. Or with a single worksheet, dynamic worksheet, a child can understand what do they mean by cyclic quadrilateral and the property of the cyclic quadrilateral, sum of the opposite angles, and then its converse also, and they can come and check it also with by dragging the vertices of the cyclic quadrilateral. Thank you. Let us learn to lead.